bestrobo.in, your favorite robotic and electronics store in India.
Hello everyone, welcome to Mifratech. Today in this section we learn about flex sensor. It is also called as a bend sensor. It is mainly used in order to measure the amount of deflection or amount of bending. So this is how a bend sensor or flex sensor will look like. It mainly has two terminals, as you can see. One we have to connect to the analog values in order to read. One more we have to connect to the ground. So it is a flex sensor with 2.2 inches in length. It has a 2.2 inches. So the resistance of the flex sensor, so mainly how it will work means, whenever the flex sensor will be blend, whenever we bend that flex sensor, the resistance of the flex sensor will increase as the body of the component bends. So the sensor like this will be used in different application like hand gesture movement in order to do that, or can be used as a zoe sensor, robot whisker sensor, a primary component in creating sentience of the animals. So in a different application where you want to measure the amount of deflection or bending, you can make use of this flex sensor. So this sensor works by bending the sensor itself, as I told. So as the sensor is being fixed or bent, the resistance across the sensor is increases. So whenever the sensor will be bending, so at that time the resistance across the sensor will be increasing. So based on those variations, the sensor will measure the amount of deflection or bending. So the greater the angle of bending, the greater is the resistance. So how much ever angle it is bending, that much resistance will be increasing. So this can be tested with multimeter also. So the resistance of the flex sensor changes whenever the metal pads are outside of the bend, like whatever the flex sensor it is, whenever it bending, the resistance will be changing. That we can measure using multimeter also. So a flex sensor, sometimes we can call it as a bend sensor, as I told. So it is a device that measures the amount of bend or angular deflection. So usually a flex sensor, it is made up of variable resistive surface. So the flex sensor mainly made up of some resistive surface, resistive variation, the surface will be contains of resistances. So the variation of resistance will be measured. So the amount of resistance varied, that will be like whenever the sensor is bent, that will be calculated in order to measure the actual deflection. So since a flexor sensor is basically a resistor, as I told, it mainly has only two terms because it is nothing but a resistor itself. So it has mainly two terminals. So what are the different types of flex sensor available? So depending on the type of resistive material used on the surface of the flex sensor, there are different flex sensor available. So like a carbon resistive flex sensor is there, a capacitive flex sensor, fiber optic flex sensor, conductive ink flex sensor. So carbon resistive type of flex sensor, now sometimes we can call it as a velostat flex sensor also, which is the commonly used flex sensor, that is a carbon resistive flex sensor. So what are the features of this flex sensor? It has a life cycle of greater than 1 million. It has a height of 0.43 millimeter. It has a temperature range of -35 degrees to 80 degrees Celsius. It has a flat resistance of 25 kilo ohm. It has a resistance tolerance up to 30 plus or minus 30% tolerance it has. The bend resistance angle will be between 45 kilo ohm to 125 kilo ohm. That depends on the bending radius. The power rating will be like 0.5 watt, watt power rating it has. So what are the applications of this flex sensor? Means it can be used in hand gesture movement recognition, or medical instruments, in peripherals of computer, robotics applications, in physical therapy, in a virtual, like in gaming, like virtual motion in order to detect, in musical instruments. So there are a lot of application where you want to measure the amount of deflection or angle of deflection. This bend sensor or flex sensor you can use. Next we'll see how to interface this flex sensor with Arduino. So it has mainly two terminals, as I told earlier itself, like how a resistance has. So one terminal will connect to analog pin through a resistance, and one more will connect to that is will provide power supply to that 5 volts power supply. Another terminal will connect to resistance. So this is the simple connection in order to connect this flux sensor. As you can see in the circuit itself, I am showing here. So the flex sensor, one terminal are connected to pin number A0, that is analog pin of Arduino Uno microcontroller, and one more end of that flex sensor after connecting connected to one resistance here of 47 kilo ohm resistor I have connected. So one more like another terminal we have to provide a power supply 5 volts, and one another end of the resistance I have connected to ground. Like that only I have interface this flex sensor with the Arduino. So this is the sample code for this flex sensor. Like we have, as I connected to pin number A0 of Arduino Uno, so that I have defined earlier itself. After that we'll define some resistance values, and using this sample code also we can do the like we can interface the dump this code, and we'll see the output using this flex sensor. It will like it will calculate the amount of bending or any hand gesture movement you can recognize using this flex sensor. So thank you for watching the video. Thank you.